Can you hear
Hello.
me, Sham?
Yeah, yeah. Hi.
Hi. So now it is streaming on YouTube live. Okay.
Okay.
So people are gonna ask you questions in the YouTube live chat. So
Cool.
I'll keep a track of that. And
Okay.
so whenever you wanna take questions, just do let me know so that I can tell you the questions and you can answer them. Yeah.
Okay. Sure.
Yeah.
Uh,
So okay. I think we can start it now. Let me just check whether people are joining it or not.
okay. Okay.
Yeah, so they are joining. So hi Sham, welcome.
Oh
So
yeah.
I mean,
Thanks.
first of all, I really want to thank you so much for agreeing for this.
Oh, yeah.
Um, and also, so hello everyone. We have Mega Sham here with us today. So
Hi
he's
everyone.
gonna teach you all physics. You have no idea how many people are so confused and they've been asking about physics. They just kept on asking us questions about physics and all of that. So today we have a person here with us. You can actually target him today and ask him questions, whatever you have, whatever the questions you have, and also regarding examinations or whatever. You just send us questions on the chat box so that I can tell him and he'll be answering. Yeah, once again, thank you, Megasham. And also, yeah, so he's an alumni of Azim Premji University. He has done his bachelor's in physics. So I think you can introduce yourself better.
Yeah, yeah.
So,
So thanks so much, Srija, and hello everybody. This is the first time I think I've ever been live on YouTube and Zoom, something. So yeah. So I've studied BSc. So I gotten my BSc in physics from Azim Premji University. So I've graduated in the month of May 2020, and yeah, it's nice meeting all of you. And so I too have no idea about what to say to all of you about the exam or like admission test, because when I was writing the exam there was only one exam, which is I think what's presently called the SAT, or no, the NET without the descriptive part. And now that there is a new part, and I don't really know, I don't really have an experience of writing it. So maybe I'll take some questions in the beginning, then I'll tell you what I think would be an interesting way to prepare for the exam. So let me just take few questions. Srija, would you mind getting some questions from all the students?
now they just started joining.
Okay.
Um, and yeah, let's just wait for it, like wait for 30 seconds or something so that we might get some questions.
Yeah, cool. So at least among all the people who have joined, let's talk about physics in general. Why did they want to, do a BSc in physics there, and like what are their interests and all of that? Let's see.
um, so none of them are asking questions.
Okay.
um, Maybe like you can just start talking about what you wanted to so that we might get questions once you start.
Oh yeah. I mean, I also want to know about their interest in physics. So if there is anything of that sort, if we want them to it's kind of an icebreaker. So it need not be something very serious or professional or something. So maybe what are their thoughts on physics program or something like that.
Okay.
Yeah. So I've also opened the YouTube link.
Okay. So they're just asking you to explain the previous question papers, previous sample papers, and yeah.
Yeah, yeah, okay, that makes sense. So the thing is, what APU is doing right now is I think the descriptive part is only part in the exam which is related to your major. So they're trying to ask you a few questions which are going to test your knowledge on the subject. So like how much physics. So it's so the thing is there you have to explain the problem in your own way. So there might be one correct answer, but since it's a descriptive thing, it's a subjective thing. You can, in some sense, attack the answer in different ways, in the ways that you know. So, so if we check, where is share screen? Wait, just a second, I'll just share screen.
Yeah, okay. So whatever the questions you guys are asking us from last 2 to 3 days, yes, we'll send it to him, and then he can answer those questions. You don't worry about those questions you asked previously. But now, if you all can actually talk about why do you want to get into physics, or why did you choose physics, all of that, you can respond now.
Yeah.
Um, So just answer, why did you all choose physics? Somebody says I think physics is easier.
Okay. Okay. So easier in what sense?
They just say,
Yeah.
okay, you started sharing your screen.
Hmm. I started sharing this descriptive paper. Uh, do you see that?
Yes, yes, I can see that. Can you zoom it little bit?
Yeah. So physics being easier is an interesting answer in some sense, because it is. I think the questions and all of that are relatively easier, at least in the descriptive component sense, and also, um, so
So somebody says they wanted to explore physics.
okay, okay. So what is that you miss in your undergrad? No, no, no. In your plus one, plus two, and that you want to explore. So the next in your undergrad program. So if that's a question you want to ask, then maybe like the answer that I would guess would be like you may have your own answer, but something that allows you in your undergrad program will be understanding physics by itself than preparing it for an exam or something different. Maybe like do some experiments and like understand, like be a part of the scientific community. So that could be an interesting way. And in the same way, APU is also looking for people who can do physics, uh, right? So that way, they are trying to ask you these questions by which they would like to understand what's your approach to solving these problems. So, so for instance, this problem particularly, let's read it out. Is it visible, Srija, everyone on the screen?
Yes.
Okay. So here they're saying a botanist is measuring the distance of it, measuring the height of a tree using an instrument called a clinoscope. This is just a small telescope with
One
cross.
second, Sham. Just a second.
Yeah,
Can you zoom in a little more?
yeah.
Yeah. Huh.
This
Yes.
is going out of the.
Uh-huh.
Okay, this must be good. Is it okay?
Yeah.
Yeah. So they're saying that a botanist is measuring the height of a tree using an instrument called a clinoscope. This is just a small telescope with crosshairs, which can be mounted at a convenient height, and the angle made by the telescope with the horizontal can be measured. Botanist finds the angle of elevation from the top of the tree uh, is the 45 degrees. The instrument is mounted at a height of 175 centimeters. The distance to the base of the tree is uh, 3 meters. What is the height of the tree? So here we have, so I hope everyone understood the question. So is the question clear first of all? Like, I mean, just put it on your chat box, yes or something, if the question is clear or not clear.
Your voice is not clear, it seems. I mean, it's clear to me,
Oh,
but maybe on YouTube Live, it's not clear, I think.
okay, so if the text is clear, let's look at the question. So let's give a couple of minutes to everyone to like look at the question. Is the
Yeah.
question is the paragraph visible on YouTube? Can someone
So,
say? So if it's the case, then we can give people a couple of minutes to like read it out.
so they're asking you to explain the question itself instead of reading it out. They're asking you to explain the question.
Okay, so I mean, I want to know what you guys have understood first of all, because that's more important, I guess.
Yeah.
So, what did you get out of the question? Like, what do you like? How does this sound like? See, this is generally not a question that comes in our IP examinations at all. So, this is something that they have designed by themselves. So, what did you understand? I mean, it would make more sense, like if we have everyone on the Zoom call so that they can unmute themselves and like say. But anyway, like put it on your chat box. Just type out what you've understood.
Not
Or
visible for them.
so, okay, I am. Is it not visible at all?
Um, like what? If you can zoom it to one point, what's happening?
Yeah,
This can be fine. I think.
yeah. So just read the question. So it might look so big as a question, but it is not actually. Like they're just giving you lots of description about the question. So
We
I
should
want
find
all.
height of a tree.
Ah,
They're saying we should find height of a tree.
yes, yes. And so height of the tree and what are the details given? If I ask that,
475 centimeters. Somebody says.
yeah. So 175. I think it was a typo. So okay. So what they've said is, yeah. So the thing is, there is a tree, and botanist. Who is a botanist? A botanist is a person who deals with plants and stuff, right? Like, so yeah. I mean, yeah. So then you have what the small telescope sort of a device using which you can look at things and like measure angles. So they're saying that from this point they have seen the top of a tree, and that is measured to be the angle of elevation is measured to be 45 degrees, and this is the height of the tree, and the height of the stand is 175 meters, and this distance is 3 meters. Like the distance from the clinoscope to the base of the tree is 3 meters. So this is 3 meters. So now what do you have? Like, okay, fine. Let me ask you, what is your strategy now to solve this problem? How do you solve this problem? Give me some techniques, or like, I mean, tell me what topics would you use?
Distance between person and tree is 175 centimeters. Somebody says.
No, so that is no. So 175 meters is not the distance between person and the tree. 3 meters is the distance between person and the tree. 175 meters is the height at which this clinoscope is standing. Like the height at which you're observing this whole thing is 175 meters, 175 centimeters. So I mean, I'm asking you what, how do you approach this? What do you have to use here?
Using tan theta, somebody says.
Yeah, so this is a problem that involves trigonometry. Exactly. So, of course, you are absolutely right. You take the tan of 45 and you construct one right angle triangle here. If you see my mouse pointer, I'll trace the triangle that I can see. So, from this point of the clinoscope, it goes all the way to the trunk of the tree and to the top of the tree, and you trace it back towards the clinoscope. So, this is a small right angle triangle. Then here you'll measure. So this is 3 meters, and since tan 45 is 1, you'll get, I mean, the opposite side to the adjacent side will be 1 because tan 45 is 1. Then you don't know what is the opposite side, but you know the adjacent side to be 3 meters. So you get height from this point to the point at which the clinoscope touches the trunk to be 3 meters. And you have the extra height of the clinoscope. So that will be 175 centimeters. So the total height of the tree will be 3 meters plus 175 centimeters. So do you understand?
Uh,
So do I explain it again? Like,
just one person said that it's clear.
yeah.
Yeah.
Okay, so this is one basic trigonometry problem. There's nothing much, but the thing is, the thing is, you have to, write your solution like how you write in your IP examination. So there you have to be clear about the details you give them, like what is given and what is to be find out, and your reasoning behind it. So you have to say, 175, like you have to write it down. The problem here is not just in terms of solving a problem, like giving the answer itself, but the way you go about it. You should be giving them a step-by-step description, and that too not very detailed. You know, like just one point. The point here would be, the height at which we are observing is 175 centimeters. So you have to construct a new triangle, something of that sort. There will be one key point which they'll be looking for. So you should not be, going in a very detailed way, like you saying, 45 degrees is this and height of the triangle is X. And like, like sometimes we expand our answers a lot. I think that's what we do in our public examination. So that should not be done. That is one thing to keep in. So you have to be brief. You have to give your reasoning proper, and you have to give some sort of a solution. The whole, I think whatever I've like learned in my APU like college, like completely would also with, like they concentrate so much on the process, like the way you approach a question than getting the answer at the end. So you have to give your, so firstly you have to be brief and you have to give the reason properly, and then you have to achieve the answer. So the questions won't be very difficult, but the thing is they are rather constructed. They're not taken from any textbook. And also these professors would sit down and they would be like, okay, let's ask these questions to all the students. So they'll be, so this is an easy question of a start. So let's go to another question. On earth, you travel 1 kilometer south, 1 kilometer east, then 1 kilometer north, and you reach the and reach your starting point. How can it happen? What are all the different possibilities for a starting point, so that this can happen? So, okay, does the question make sense? You have a globe, someone's traveling 1 kilometer south, then 1 kilometer east, and then 1 kilometer north, and you reach your starting point, it seems. Is it even possible? Like, what is it? 1 kilometer north? So you're, so if you're like these are all directions that are perpendicular to each other. So in some sense, you are like just mapping three sides of a square, but so you have to travel one more kilometer, right? To like 1 kilometer west is sort of missing to sort of come to the point where you started. So how can this happen, or what does this mean? And you guys like does it? So what? So does the question make sense? And what do you think about this question? Are we having any responses, Rija?
Not yet.
Okay. So it's an interesting question. You have to think about it. It depends on the geometry of our globe itself.
Somebody says it is possible if we move in clockwise direction.
Okay, clockwise meaning we're going south, then yeah, south, east, and east and north. Yeah, but where is it possible on Earth? So where do you, so they're asking, how can this happen first of all? And what are, so if you have to draw a diagram, how do you draw it? You have a pen and a paper by your side. I want to ask you all to like draw a small diagram to like explain what how can this happen. Any idea, like any thoughts on how can this happen?
Uh, Not yet.
Okay.
So only that one person responded. Maybe starting point is west. Somebody says maybe the starting point is west.
Okay, but west of what? Because you started one point on Earth. So where do you start? I want one like you have to justify it, right? Like where do you west of what? Because on a globe, you have east and west and north and south at any point.
It is possible in circular motion.
Ah, yeah. So that little bit takes us to the answer. Let me just pull up a picture of. Okay, is Google Earth available?
And somebody says no, sir. It is an anti-clockwise direction.
Okay. So I mean I'm also looking at this question for the first time, so I don't really have an answer, but I have some idea about the answer. Like how can so it is said that you have to go in the clockwise anti-clockwise direction. Like what does it say? What does it say?
Started from north. Somebody says started from north.
Okay, north like north of what? Like you mean North Pole or uh, north of India or north of our Telangana, Andhra Pradesh? Like where?
What if we move in a square type? Someone says.
What is it?
What if we move in a square type?
Square type? I didn't understand it.
That even yeah. Um, Somebody says clockwise direction.
Yeah, okay. I mean, I understand the direction part, but I don't really get what do they mean by clockwise or anti-clockwise. So I don't know. So the thing is, so here, do you see the globe here?
Yeah.
Huh? Do you
Yes.
see the
Yes.
globe?
Yes.
So let us read out the question again. They're saying 1 kilometer south. 1 kilometer east and 1 kilometer north, right? So the thing is, on Earth, north of anything will point you towards the North Pole, right? So there is no up as such. Like here, I mean, since it looks flat around us, the Earth, we don't see the curvature. Like we don't see Earth curving around, right? So here at the North Pole, like imagine that you are at the North Pole, all right? So then let's say you're going down 1 kilometer south. So I've come 1 kilometer south here and I've gone 1 kilometer east. Then I'll go 1 kilometer north again. North meaning I'll be going towards North Pole. Like if you imagine yourself to be at the point on the globe, then the north that your compass or whatever is telling you the direction would point you towards the North Pole only. So if at any point on the earth, if you start going towards north, all of us would end up at the North Pole. I think we agree at that point. So here, if you come 1 kilometer south, 1 kilometer east, 1 kilometer north, you would end up at the North Pole. Like you begin at the North Pole, then south, and yeah, I mean, and also south will be pointing towards the South Pole. So at the North Pole, if you start 1 kilometer towards the south, 1 kilometer east, and 1 kilometer north, you would just go back to the North Pole. So this is the tricky part of the question. Does it make sense? So let's say here we are in India. Let's just zoom. Let's go to Hyderabad maybe. So here we are. Here is Hyderabad.
Yeah.
Then if the thing is on like here in Hyderabad, if you go 1 kilometer south, 1 kilometer east, and 1 kilometer north, you wouldn't end up at the place where you have started, right? It will just be uh, you can think of it as three streets, one junction or something, which are perpendicular to each other. Like you begin here, you go down south, then you go towards your right or left, towards east, then you go up in the direction of north. Then you would just be covering three sides of a square sort of a thing, but you won't end up at the point where you begin. So here what they are saying is you have three 90-degree angles because north, south, east, west are all 90 degrees to each other. But in some sense you are doing a triangular motion. Okay. So this is possible only when you have your three sides to be curved. Does it make sense? Do you agree with the reasoning? Let's go to the North Pole. Are we at the North Pole? We are almost at the North Pole. Where's North Pole? Hello? Is anyone saying anything on the chat?
Um, yeah.
Like,
The,
does the explanation make sense?
so they're asking you to show the question once again. And
Okay.
so when you asked what do you mean by that clockwise, they're saying it's the rotation, the clockwise rotation they're saying, which I really didn't get. And
Yeah,
also,
yeah.
and then few of them are saying yes, they understood. And so they're saying it's possible through square.
Hmm. So the thing is, on Earth, like, I mean, if you are somewhere, away from the North Pole or wherever, then you will move in a square path. Like here you are, 1 kilometer south will be like this, 1 kilometer east will be like this, and 1 kilometer north will be like this. So you would just be covering three sides of a square like this. But here they are saying that these three are, like the person has ended up where they began. So it is in the point here is you are on Earth, which is not a flat land, but a sphere. So on a sphere, you'll be taking a path that has a curvature. Like you are moving towards a curve on a curve. It's not. It might seem like a straight line, but it's not really a straight line because we are all living on a globe. So I hope you all agree with this. And yeah, there are these big jokes about Earth being a sphere or a flat line. So yeah, so here you are on a sphere and you come down, and here, like, I understand, like, you are moving anti-clockwise or clockwise. So I mean, I am really bad at these directions unless I like have pen and paper. I can tell you correctly, but I agree with you. Like your intuition must tell you if it is anti-clockwise or clockwise. No, clockwise is this, anti-clockwise. Okay, so your intuition would should tell you which how it's possible, but here the point is more on you've begun at one point and you've ended up there itself by traveling 1 kilometer in perpendicular directions. So that is this question's about. So I've put up the question again. I think you've read it, and yeah, I also request you to like go through these papers. These are available on their page. So you have three question papers given, so you can go through each and every question. And I would say discuss it with your friends. Okay, so let's go to this other question. I hope there are no questions on that one. Are there any questions on that one? They can put it up on the chat box.
Um, somebody says if we move intention initially, I don't know, intentionally, he says to starting point, triangle motion is possible. Um, maybe he meant to say intentionally or initially. If we move, I don't
Okay,
know.
let's
So
do
he
one
just trying
thing.
to say
Let's
that if the starting point is a triangle motion, then it is possible. He says, yeah,
Okay, but here the thing is they're saying it is they're going 1 kilometer south and 1 kilometer east and 1 kilometer north. South, east, and north are perpendicular to each other also. That is one thing we have to keep in our mind. So the thing is the triangular motion is happening, but sum of all angles in a triangle is 180 degrees. We know that. Here the angles covered by each and every person are 90, 90, 90. If you add 90 plus 90 plus 90, you get 270 degrees, which cannot possibly be a triangle on a plane, right? So angles and properties violated here. So you should either say it is impossible at all or it is possible on globe at some point. So so how it is possible and all is the question. So that is a key point here. Maybe like okay, so let's do one thing, Srija. Maybe you take the responses, let them write to you over mail or like phone texting or however. You can forward those questions to me so I can help them.
yeah.
Oh, okay. Now here comes a nice and interesting physics problem. They're saying an electron initially at rest is placed in a uniform electric field of strength 10 Newton per Coulomb. So they're giving your electron like electric field in which an electron is placed. So what happens to the electron? Calculate the acceleration of the electron if any. So what is the velocity of the electron after 10 seconds? Draw a simple picture uh, showing the direction of the motion of the electron. Assume that the mass of the electron is 10 power minus 30 kilogram. The charge is 10 power minus 19 coulomb. You may neglect any effect of gravity. Okay, so what do we understand from this? So explain me what you understand, what is being asked, what is this question? So so check. Okay, someone saying the electron will revolve in the electric field. Will it actually revolve though? Is a question, because it revolves. It goes round in a magnetic field because you have Q into V cross B as a formula, right? So Haritha Kondal is right by saying we reach the same point because Earth is sphere. So yeah. So the thing is, you have to reason the questions these way. Like you have to say if it is possible or not. So you have to write it. You have to explain what your thinking is and all of that. Mm. So okay, I think I'll share this one here for your electric.
They're asking you to show the question again.
Yeah. Okay. This is the question. Is it visible?
Yes, yes.
Yeah, an electron initially at rest is placed in a uniform electric field, strength 10 Newton per coulomb. And what happens to the electron? Is a question. Calculate the value of the acceleration of the electron, if any. So what is the velocity of the electron after 10th second? Draw a simple Draw a simple picture showing the direction of motion of the electron. Assume that the mass of the electron is 10 power minus 30 kilogram and its charge is 10 power minus 19 coulomb. May neglect the effect of gravity.
I think
So
you can go back to that PPT.
yeah, yeah. So here is the thing. So if you have force on a particle that has mass, then the Newtonian force on it will be times the acceleration, and force on an electron in an electric field will be uh, charge of the particle times electric field. So here then what do you have to do? You have to equate mass times acceleration with, which will be equal to q times electron. So here if you see, so A is a vector, acceleration is a vector, mass is a scalar. Then you have q, the charge of the electron is a scalar, and electric field is a vector. So the acceleration will be in the direction of the electric field that is given. So electric field, whatever is the direction of electric field, you have acceleration in that direction only. So that means it possesses some acceleration, because since it has mass, force on it should be a mass times acceleration. Since it has charge also, if it's in an electric field, then the force will be q times e. Then your acceleration will be okay, acceleration will be equal to q hold, q divided by mass into e.
Uh, so they're asking you to zoom the screen, and also somebody says that acceleration would be 10 to power 12.
Yeah, okay. I mean, I haven't done the calculation, so I believe that they're right, and it should be something somewhere in that order, right? Do you see this? Force on a particle, force on a particle, if it has some mass m, will be mass times acceleration because it's an acceleration. Force on an electron in an electric field will be q times e, where q is the charge of the particle and e is the electric field. So mass times acceleration will be q times E electric field. So acceleration will be q by m times E. So this is the theory that is behind this thing. And then, so there they haven't given you any direction. So you have to assume a direction, you have to draw a diagram for them to explain, this is how it's gonna move. If it has an acceleration, so it is initially at zero velocity. So after some acceleration, you have some velocity v. And you can find with those three, so you can find these things with what v square minus u square equal to 2as, v is equal to u plus at. Those formulas are there, right? S equal to ut plus half at square. Using those formulae, you can find what's the velocity gonna be of a particle after 10 seconds. So, and v is equal to u plus at. I think that's what you would use here. A is this value, q by m times e. Uh, so then you have what final velocity is equal to initial velocity is 0. So you have that acceleration times the time 10 seconds. So I hope that's clear. So are there any questions on that? I think it's simple enough to like understand. So you have what? You have the mass, you have the charge, and they've asked you, like, what is the principle? So here is the thing. So okay, the solution looks simple, but just read the question again. So they're saying an electron initially at rest is placed in a uniform electric field of strength 10 Newton per Coulomb. What happens to the electron is the question. So what happens to the electron? You have to explain them what's going to happen to it. So it's saying, okay, it gains some force. So it'll possess some force. Then you have to say what is that force. So that's the force by the virtue of the electric field. You have to explain these things to them. You have to describe. But if you just put formulae by saying ma is equal to qe and all of that, that is not really what they're looking for. They're looking for what's actually happening in your head, like what's the physics behind it is what they're asking you. So you have to explain the physics behind it. So it's more of a question of that sort. So then, so here, if you read the question, it's put cleverly. They're saying calculate the value of acceleration of the electron, if any. If any meaning, if there is any acceleration, so they're not really giving you, they're not really asking you to tell them the acceleration. Okay, they're asking you if there's any acceleration, you have to describe it. So first of all, you have to justify why there is an acceleration. So why there is an acceleration? If you ask me that, then you say, okay, it's in an electric field, so there'll be force by the virtue of the electric field. And since it has a mass, and Newton tells you the force of any particle if it has an external force on it. Here the external force comes from your electric field. So the external force is that, and that external force will be mass times acceleration ma. So that's your ma, and ma is equal to qe, and that's how you explain your question to them. So explain your answer to them. Okay. Then the next question is what is the velocity? So you have to read the question properly, and for each and every question you should be answering. So you put an answer in your description. So that's why it's called a descriptive exam, right? You have to describe describe your answer to each and every question that's asked. What is the velocity of the acceleration? That I like we've discussed. You use u v is equal to u plus at formula. Then here is the interesting part. So draw a simple picture showing the direction of motion of the electron. That's another interesting thing that you have to uh, you have to discuss. So I can't like draw an image right now because A, I don't have a pen and paper, and B, I don't know if how to share the pen and paper thing with all of you on a video call. So okay, that's there. So there you have to draw a diagram showing what's the motion gonna be, and then they've given you these details here. You don't have any question. It's hard. They just given you, this is the these are the values.
Yeah. So somebody says u is equals to 0,
Yeah.
and then somebody says velocity of an electron is b is equal to a is equals to 10 to the power of 13.
Okay. Cool. Yeah. I mean, I believe that. Okay. So yeah, so that's about this question. So which is mostly which involves concepts from electricity and magnetism. And this is the final question in this question paper. So draw the shape of a drop of a water floating in space with no gravity or air. So there's no air, there's no gravity. To draw a diagram of a water drop, how it would look. Then moment after it gets leaked from gets released from a leaking tap, drop by drop, in gravity, but without air. So, and what do we have again? So, raindrop falling under gravity, but in vacuum. A real raindrop falling in gravity through air. Give brief. Okay? So this is an interesting question. So how do you approach this? This is straightforward, and you have to draw how a drop of water looks in different scenarios. How do we approach this? So these are all, in some sense, I would say mind questions. Like you really have to, observe
They're
these
saying
things.
rhombus.
Oh, rhombus.
Mm.
Okay, I don't know, but maybe so. These are all like what we have to like have to. Okay, how do you justify that answer? So the thing is here, they're saying give brief explanations. You have to give them as explanations for your answer. So you have to draw the shape. You have to say why. So here is the thing. Let's say you got the shape wrong, but you say you got the reasoning right. Then they would be like, huh, okay, this fellow, no, they wouldn't. So this fellow doesn't know how, like, this might not be right about the shape actually, but the reasoning is enough. So there you would get a mark. All right. So it's something like that. So the point here, so if you just draw diagrams and if you don't give explanations or anything now, then so you'll be losing over there. So though you got, so you we might not be knowing, actually, like for instance, I can't imagine how a water droplet is gonna look in vacuum but gravity, because I don't think there is ever a situation where you have gravity like on Earth, like wherever in our everyday lives. I don't think there is any scenario where we have uh, gravity but no air. So the key point here is, there is gravity which is going to determine part of the shape of the drop, and you have air which pushes the drop again. So you have the air resistance for anything. So an air resistance will be a thing, and you also have the gravity of the drop. So like how gravity is going to determine the shape. So these are the things that they are really looking for here in this by asking this question. So you have to say, uh, so here you have finally a real drop falling in gravity through air. How does it look? So that looks like our general this type of a droplet. So why does this shape come is what you have to think. So there's going to be air resistance. So what's air resistance? So how is air going to determine the thing? So there are no, it's more of how you are thinking about these questions than you are solving all of them properly. So that's where the key lies in here. So are there any more questions? Like this, does the explanation make sense?
Uh, Somebody says we can't assume.
Well, there are so many assumptions made in the subject of physics itself, and so that's an interesting point. But at the same time, it's more about the reasoning you do, and you have to make reasonable assumptions. So
Yeah,
that's
she
another
says.
key.
She says. Sorry. Oh, okay. Sorry, deleted.
Okay. Okay. So yeah, you have to make some reasonable assumptions. Like I myself, like right now, wouldn't be able to answer this type of a question so properly. So yeah. So but still that doesn't mean you are losing so much here. So you have to. It's more about how you reason these questions out and like tell them what's gonna happen. So yeah, I think we have taken a lot of time on like one paper itself, discussing the paper. And these are all, questions that are simple enough. And they have put three papers for you. Two past papers are there, and one sample paper is there. So I would ask you to go through those questions, each and everything. So and also like sit with your friends who are also interested in like solving and
Yeah. So
all those
she.
questions together.
Sorry to interrupt you. So she says that because there's no gravity and nothing would float, we
Hmm.
cannot assume. She meant to say, I think.
No, so if there is no gravity, you don't have anything that's allowing it to fall down, right? So it would just stay over there. So it'll just be, a spherical water bubble, which is not a bubble, like spherical drop, which is floating in space. A drop of water will be spherical in shape, right? If there is no water nor air. That's what I think, floating in space with no gravity or air. So the question answer for air. So what is the question again?
What's her question?
No, no. I think someone you were saying you were just explaining me some comment that is put up, right?
So, yeah, so first she said we can't assume, and then
Yeah.
she says because there's no gravity, nothing would float.
Now, if because there is no gravity, everything would float. Isn't that the point? Because if you don't have gravity, that means you don't have anything that's falling down.
Yeah, so raindrops
So,
are traveling towards gravity on Earth, but
hmm.
cannot visible in a particular shape, even in a vacuum.
Oh, that's an interesting answer. Okay. Yeah.
We cannot
Um.
determine the shape without the gravity.
Oh, okay. So, so what actually determines the shape? Okay, that's an interesting answer. I do have to think about it. So yeah, so the thing is, most of the drops out of a shape like this is mostly determined by the air resistance that a drop sees. So you have a drop that's falling down. So that's I think that's the answer here right now. So you have some amoebic shape of water if it's just falling down the thing, or by surface tension of the water it would still be a sphere, because though you don't have air, you have the surface tension, and as the surface tension tells you, it keeps the minimal of all the surface area. So that would mean that it will still be spherical water. So we know the surface tension of water, right? So like the property of surface tension, like it tries to keep the area minimal. If you have air and it is falling down, you have air pushing it back upwards. So you have that and water drop coming down. So that gets balanced by attaining this shape by water. So that is a key about a real raindrop falling in gravity through air. So yeah, what I have to say. Okay.
Somebody
Uh,
says shape depends on surface tension.
Yeah, exactly, exactly. So these are different ideas that people are looking for in this exam. So whoever is correct in this paper. So you have to The thing is, you have to write all these explanations, what you think and all of that. It's okay if you don't arrive at the proper answer, but the thing is, you have to explain what's actually happening inside. So yeah, like as a good physicist, you should not be, you should make good guesses, but you shouldn't be, believing what you've guessed, what you've assumed. Like someone said, you have to make assumptions, and that won't make sense. So exactly, you have to make right assumptions, but at the same time, as a good physicist, you should not believe until you like conduct an experiment and like verify the results by yourself. Of course, you can't, conduct an experiment in an examination while you're writing the exam. So what's more is expected here is good reasoning and good explanation. So good explanations meaning it's not like you're describing so much in paragraphs and all, but getting the physics right. Like the term surface tension itself would be something that they are looking for, right? You shouldn't be explaining as a school child. Like you shouldn't be telling a lot by writing paragraphs and paragraphs of how this is going to look and all of that. So you should use your physics here. You have to explain each and everything by some physics principle. Then you would do good. Yeah, I think each paper would take an hour by itself if we like, keep discussing. And I've discussed one paper, and there are two more on the website I found out. And when is your exam? May I know when's the exam for all of them?
On Jan 10th,
Oh, okay, okay,
like on
okay.
Sunday.
So
And
that's
also
good.
they're asking you to suggest um, what kind of a topics and concepts that we should learn to prepare for this.
Yeah, I don't think they were present anywhere. So as a preparation, so I've just made this a small presentation itself. So physics has these main topics in itself. Like these are uh, pretty basic. So you have mechanics, you have thermodynamics, you have electricity and magnetism, you have optics, you have waves and oscillations, and you also have. I mean, this is not a topic by itself, but they also ask you on the math part, mathematical. Like your first question, top of the like you have full tall tree and that sort of a thing is more of a math question than a physics question. So you have mathematical. These are like the broad areas that are of our interest. And I have divided and I have also tried to describe the subtopics. So here, what I'm trying to do is I'm trying to build a small structure of like all topics that are there in physics. They are generally there. Like if you're preparing for JE mains or MSET or any other entrance exam as such, you would also know that these are what each of these topics constitute of. So mechanics has what kinematics, basic velocity, displacement, acceleration, those things. You have laws of motion, which deals with force and everything else. And then you have work energy power. Work energy power is an interesting and important exam because it talks about conservation of energy and those topics. You have work equal to energy and all, and you have what is power and things. And rotation motion is there. Usually it's a difficult topic, but you still have some things to like understand. Like I would say our whole 1 kilometer south, 1 kilometer east, 1 kilometer north is more of an rotational motion question because you need to have an idea of a sphere and like rotations there. So of the earth itself. And then you have gravitation, like uh, you have masses attracting each other, the g m1 m2 by r square and those formulae for mechanics. And so this is what I've prepared as the list of all topics under mechanics. And since mathematical physics is what I think that is interesting, or no, what I think is essential for this exam. So mathematical physics here you need to know what vectors are. Vectors meaning vectors and geometry also. So a bit of geometry and vectors. I'm combining geometry into vectors, and you have 2D and 3D vectors, dot, cross product. So ideas of like vectors like directionality, like for instance electric field. Like in the problem we have solved, electric field and acceleration are vectors. So you have vectors that you need to learn about. And you have trigonometry. Basically the first question is all about trigonometry. And you have what, calculus. You have to do it. You should be able to do differentiation and integration. I don't know if that will be asked in the exam. It might be. They can ask these questions, but not like too complicated questions. It's more about your reasoning behind like what's being asked and all of them. So yeah. And yeah, so these are in some. So you have to, I would say, write down all key topics and write down all subtopics. notes or like topics wise, in terms of your plus one plus two textbook must be enough, and like a bit of basic mathematics, like your 10th standard angle of elevation and those things. So I would say, first of all, write down all these topics down and like give explainers, like map out all different concepts that are in each and every topic, and solve some basic questions. Don't go into reading so much. Maybe solve some questions. I think all of you have access to HC Verma. HC Verma has these subjective short answer type questions. So I would say go through the short answer type questions, some of them, so that you'll have an idea of what to write, or like idea of some questions, like how to answer these questions. So you go through some, or otherwise, I think I would say take your IP questions only at the end of your textbook, and like think about how would you answer them, because all of them are questions of physics indeed, right? So just think about, okay, if this is the challenge given to you, how am I going to solve it? So what is the essential physics happening behind it and all of that? Unfortunately, we don't use that approach in our schools and all of that, and there is lots of rote learning happening. I am assuming this. So, and like we have all, what do we have? We have, I mean, I've had all these guides and study materials where I would, like read through answers and all of that. But what they're essentially meant for is for you to like read each and every question and answer it by yourselves through physics. So this exam will be chill. I can assure you that. And the thing that they'll be looking for is, what's your reasoning of a given particular case with the physics, though you're not, you can, let's say, there are some question from electricity and magnetism, but you only know mechanics so much. Then, you can say what's going to be the forces on this. Like, let's say you might not say that, let's say you don't know the formula that force on an electron in an electric field is q times e. So then what do you say? You may say, there's going to be electrostatic force on this, and that will be combined by mass times acceleration. And that's how you give some reason. Like that's your. So I would say don't leave out any question. So just give it some reasoning that you have, and you do good. So yeah. So I have one task for you. The task is to jot down all different topics in physics, and like first of all, identify these different regions like mechanics, thermodynamics, E&M, optics, and all of that. Then give subtopics, make a mind map of sort. I know this is too much if you only have 3 days, more days for the exam, but I didn't know that. Anyway, so you would know at least what are all the topics that are present in your physics, and that will be useful for your other entrance exams and everything. And then later you kind of think about all these things. Maybe you brush up your concept, since they involve your first year concepts also. Mechanics is mostly done in our first year, right? So you may want to, like I think you are preparing so much, since you are in your second year. You know E&M, optics, and all these things so much so well. But I don't think you'll be knowing your mechanics and everything so good. So I would say, uh, brush up your concepts of your in your first year intermediate. So first year, so you just go through your mechanics notebooks and all more, and maybe some of thermodynamics, like first law of thermodynamics. Like it's basically about conservation of energy. And they will ask so many questions about visualization, like drawing graphs and all these things. So this is another question. So this is a little more complicated paper. I think that's the sample descriptive paper that's given to you. So you have, so we won't be having any time to discuss this, but I would ask you all to like go through this question also, and write these answers down by yourselves as a practice, like describing all these questions. And if you have friends, share your practice paper. I mean, like, the things you worked out, and like see if others agree with this or not. So yeah, things like this. Yeah. So hope that's clear, and maybe this is all I have to like say. Uh, so yeah, Srija, if you have more questions or something, we can take them.
Um, we're yet to ask question. Maybe we can just wait for a minute
Yeah.
so that get the question. You can actually direct go to the website. You all can go to the website and then just look for the papers.
Yeah, that's like I have looked them up on the website only. So there are some sample papers, and they don't really have a syllabus. So what they are expecting you is to have a reasonable idea on what you learn in your 11th and 12th. So IP level concepts and all are enough, but you have to have this ability to answer the question by yourself, like writing the solutions and all of that, like describing what's the physics going behind the question that's asked to you.
Yeah, like if you guys want, we'll share the link again.
Yeah.
But yeah.
So, and also let me advertise a little bit. But yeah, I mean, I'm not getting paid for this. And APU's physics program is fantastic. So and I would also want to say it's not like too difficult and all. But if you uh, so like compared to the other programs in the country, like in somewhere in Delhi University or ICERS and all of that. So it won't be very difficult, but at the same time, if you have the zeal for physics, if you want to work so much and all, you have great professors who are very friendly and they'll be so willing to like help all of you out. So you can do nice and interesting projects with them. You can stay in your summers and winters over there. They have a great campus. I think new campus is coming up and all, so you can do nice projects. So if you are keen on physics, and I think the key for physics at APU will be in doing a project. I don't know if you'll have. I think they're changing the program structure a bit. I don't think honors program is available anymore. But otherwise, you can work on independent projects with professors, and you can ask them to like recommend you guys to some undergraduate research programs happening in other colleges and stuff like that. So yeah.
Yeah, so there's no negative marking in descriptive writing. I mean, there are no marks only for negative. Sorry, descriptive part. I don't think
Yeah,
you have.
so this is not like
Yeah.
or any other competitive exam. What they're looking for is how much physics you know. So if it was some MCQs and all of that, then you have to worry about negative marking and all of that. So this is mostly about like your IP exam, which is where you don't have any study material or anything.
Um, I mean, Sarita, what is your question? I think I missed your question. You said, I don't know. I just didn't maybe look at your question. What is your question? Can you just ask again? Yeah, we'll try and do another session for math. Please talk about physics for now. Um, yeah, guys, if you have any questions related to whatever happened till now, please put them up here. Uh, yeah, seems like we're not getting any questions here. Maybe like you're
Oh,
clear to them.
yeah, it's okay. I think if things are a little more clear for all of them, then that's better.
Yeah.
So
Or
please,
like if you didn't understand, they would have asked by now.
yeah. And also like about the exam and physics itself, since you were telling me that they had no session or any orientation about the physics program. So I think this will make things better a little bit.
Okay. So I am sorry, Sarita. I don't know. Can you just resend that pic again so that I can tell him now? So many members are confusing to answer in physics problems. Please give any suggestion to us to think and what is a way to think to answer in examples. Maybe she meant to ask that they're so confused to answer the problems in physics, and also what is the suggestion that you can give it to them using some examples and all of that.
Oh, so the thing is, this is so vast, right? Like the professors who design this exam can like ask from anywhere. I don't really have anything much to say, but I would say, just revise your topics a bit more and like work through some questions because you might not be. So the point in working through all these questions is not preparing for the exact topics, but making yourself like familiarizing yourself with the topic and like yeah, developing your ability to answer questions. So I will say so. How I think of preparing for an exam like this is just to brush up my concepts again, answer few questions which are present already. So not like problems directly, but the questions which would require some more reasoning. Like I would recommend HC Verma's short answer questions, which are more like this. So you have to like answer, you have to describe the answer. So maybe go through questions of that sort. So that should do good. So in the next 3 days, you can like sort of do it. But,
Yeah. Um. So yeah, she sent me a problem actually. So it's a problem which is asking a stone dropped from a height keeps on increasing in speed.
mm,
Every second, its speed increases by 10 meters per second.
okay.
How much distance will the stone fall between 1.5 and 2.5 seconds after being dropped to with zero speed? Use the idea of average speed.
Oh, okay. Where is this question from again?
I mean, I really don't know. If you want, do you want me to share the screen with
Yeah,
that?
yeah. I think like share like forward this question to me. I'll work it out and like send it again because like at the moment I won't be able to solve.
Oh, okay, fine, fine. Yeah, so Sarita, he'll answer you later. I'll just forward it to him.
I want to know if this is a question related to APU exam. Like, did he find it in APU
I
exam?
think yeah. I think it's the question from one of the papers maybe, or I don't know where she's asking it from.
Okay, okay,
Yeah. So they gave some options. I'll just forward it to you so that you can just
okay,
yeah work on that.
okay.
Yeah.
If there are options, meaning I don't think there are any MCQs for
Yeah,
APU.
that's what.
I think there's some other question. But anyway, like I'd be happy to like help out.
Yeah. So somebody says 20 centimeters. I don't know why 20 centimeters. What are they answering for? But somebody says 20 centimeters.
Okay, I don't know.
Yeah. Or maybe for the question that I just read, important topic you have experience in the exam. Uh, Maybe any topic that comes in the exam. That's what they're
No,
trying
people
to
like you
say.
only have what three papers and there is no proper syllabus, so you can't really expect anything. You can't really say this is what it's gonna be like an important topic and all of that. Maybe mechanics because every exam has something related to mechanics. Let's say work on mechanics and electricity and magnetism.
Yeah.
And these are not important topics, but at least from what I've read, it seems to be that they're expecting you to know some of these things. And like the question that is asked, it has what force equals ma and force equals qe. It's both mechanics and electricity and magnetism. So there are no like questions that are topic wise. You can be asked questions that are linking different topics, but they're not too complicated. They're easy. So it is more about how you comprehend all these things. So you need to have a good idea about your physics in general. And I'm sure that anything of like all questions are like at, I mean, I would say at an IP level. So just go through your study materials and textbooks once again, just brief through all these things, and you should do good.
Yeah, I think that's all.
Oh, okay. So
Yeah.
thanks so much. And like I also
Thank
wish
you.
everyone a very, I mean, what am I saying? Okay, fine. First of all, happy New Year, and at the same time, all the best for your exam. So hope you all do good in the exam and like uh, also join in programs that you wish for and all. So, yeah.
Yeah.
And also like any other Okay. Are you also looking at any other institutes other than APU?
Oh,
Students?
the students, yeah. So many of them are also writing neat and trying for Flame University, and
Oh, okay.
also yeah, few other universities and all of that. Yeah, so
So
that.
your preparation for those things is like more or less enough for this one also. So don't worry so much. So, it's gonna be all right.
Oh, okay. So the question that he asked is from a quantitative reasoning question paper, it seems. So yeah,
Oh,
then
okay.
it has options. But yeah, okay, fine. He'll anyway help you to find that out, Sarita. You can, right?
Yeah, yeah. I mean, I hope that I can. So let me look at the question properly. If I won't be able to solve, then let me
Yeah,
not
yeah,
commit to a
yeah,
solution beforehand.
yeah. Okay. So
So if that is all we have, then we may end the call right now.
sorry.
No, if that is all we have, then we may end the call right now.
Yeah, yeah. So, yeah, we can end the session now. So, if you guys have any questions, please do send it on the group so that I can forward it to Sham. So he
Yeah,
will help you
absolutely.
in finding those.
Absolutely. So
Yeah.
I'll be happy if they're more APU related rather than any other competitive exam. But it's okay if you also like send other questions also. So yeah,
Okay.
it's
Okay, fine. That's really sweet of you. Thank you so much, Sham. So,
thanks, Rija.
yeah. Okay. So, yeah, I'll send the questions if they have any. Thank you, guys.
And also let me request you all of them to be kind and like not send other questions because I myself am scared about all these questions and all. And not a big problem solving guy. So
Yeah, but yeah, anyway, I'll be in trouble. Okay, then I'll be in trouble. I'll look at the questions, so then whichever you can answer, I'll send it to you then.
yeah, okay, that sounds good.
Yeah, so you'll be safe. Don't worry. Yeah. Okay.
Yeah,
Cool. Thank you, Sham, and thank you, everyone. So I'm just ending the session here.
yeah.
You
See
like to say
you.
anything more?
Bye.
Would you like to say anything else?
Like me or the
You only,
students?
not people,
No, no,
not.
no, no. Like, let me just wish all of them very best. And yeah, that's it. All the
Okay.
best, and you're gonna do good.
Yeah. So thank you, guys. Thanks, everyone. Yeah.
Yeah. See you all. Bye.